Howdy, it's Mr. Russell, and we're here to learn about oxidation reduction reactions, also called redox reactions. I guess redox sounds better than oxred. A redox reaction is where the oxidation state will now change. You have actually seen these before and in Chemistry 1, but you've never actually been told that it's a redox reaction. Those oxidation states, which you've understood is the charge, those are actually going to be able to change now. I just want you to remember the electronegativity. Remember, fluorine is the most electronegative element, and to remember the foremost electronegative elements on the periodic table, all you need to do is make a phone call, F-O-N-C-L. Here are the rules for assigning an oxidation state. First, if an element is by itself, say just iron, Fe is hanging out by itself, its oxidation state is 0. The monatomic elements will now just equal their charges. Oxygen is always going to be a -2 unless it's in a peroxide. I wouldn't forget this. These exceptions find a way on the test somehow. And if it's in a peroxide, like hydrogen peroxide, H2O2, its oxidation state is now going to be -1. Hydrogen is going to be a +1. Fluorine is -1. And the sum of the oxidation states is going to be 0 for the whole compound, or if it's an ion, the sum is going to be the charge of that ion. So now let's get an example for the 6 rules that I gave you before. First, if you take those 6 rules, you're going to want to follow them in order, meaning I'm going to follow rule number 2 before I follow rule number 3. So without further ado, let's look at our first one. Dinitrogen oxide, I'm going to assign a -2 to the oxygen. Now that will and I need to have a net charge total of 0, since there is no charge with this molecule. So now this subscript will actually multiply by the oxidation state. So to cancel out this -2, the nitrogen needs to be a +1. For phosphorus tribromide, I will now I don't have an oxygen or a hydrogen. So now I'm going to have to look at my electronegativities. The most electronegative is going to be the one on the right, and that's going to be bromine. And so I'm going to consider it a halogen, and there's often -1. So take a 3 times -1, so I got a -3, and then that means that my phosphorus needs to be a +3. On this next one, this is now an ion, so my net charge isn't going to be 0, it's going to be -2. So now I'm going to assign -2 and +1 to my hydrogen, to my oxygen and my hydrogen, because those are my rules. And now I need to figure out what charge to make this one to make the total net charge -2. And that's going to be a +3. I'm not going to talk for the next ones because I slow it down. You could actually get a non-integer state, meaning I would get something that looks like that. I would get 8/3 for iron. That's a little crazy, but the reason is because if that there is there are 2 different common oxidation states of iron. This is found in the Earth's core a lot, iron oxide, and the 3 plus ions are actually more common than the 2 plus ions. It's a cool little thing. Very rare. I don't think they've ever actually put it on the AP test, but it's possible. The definitions for oxidation and reduction are listed here, where we have the loss. Oxidation is the loss of electrons, and reduction is the gain of electrons. This can be confusing to a lot of students, but not if you try to think of it as the electrons. Remember, an electron has a negative charge. So if it gains an electron, it is going to reduce its charge. You see, so think about them as electrons because electrons have a negative 1 charge. We try to clear up this confusion by using the mnemonic oil rig, oil rig, oil rig. Oxidation is loss, reduction is gain. Another slogan is Leo the lion goes grr. So you lose electrons for oxidation and you gain electrons for reduction. I prefer oil rig, but use whatever you'd like. The last set of definitions that we'll have for this video are the oxidizing agent and the reducing agent. So those are the ones that are often found in pairs with something that is oxidized or reduced. That is the one that's actually doing the oxidation, or it's the one that's doing the reduction, respectively. They're not tested on the AP test, but they are helpful to know when we do our labs. Let's work through some examples. When you get a redox equation like this, it's helpful to start with the oxidation states first. Then try to see if you could identify and see which states are changing. So I know that the potassium is a plus 1 over here and a plus 1 over here, so it's not changing. The iodine is a minus 1 here, but a 0 over here. The fluorine is a 0 here and a negative 1 here. Use some visual examples to try to help you along the way. I've drawn iodine in red and fluorine in blue to show that one of them is being oxidized and one of them is being reduced. I can now look and see how the charge has changed. It went from negative 1 to 0, so that means that it lost an electron. So an electron is lost. And now I can see that an electron from fluorine, since it went from 0 to negative 1, an electron was gained. Now we're able to understand and see which one is oxidized and which one is reduced. So the oxidized one is going to be the one that lost electrons, that's iodine, and the one that's reduced is going to be the one that gained, fluorine. The oxidizing agent, or OA, is going to be F2, since that is the pair that came along with the iodine. And then likewise the reducing agent is now just going to be the opposite pair here that came along with the fluorine. So now with this example, you would have lead oxide decomposing to lead oxide and oxygen. So before, you guys have asked me, why do I need these Roman numerals? Well, now you'll get to see why the Roman numerals are important. So this is a lead oxide and this is a lead oxide. The only difference is their oxidation states are different. This would be a lead 2 oxide and this would be a lead 4 oxide. Now that you've assigned the oxidation states, go ahead and draw your tie-ins. Draw those little boxes just to see where the states are changing. If you pause the video and try to draw them yourself, you might have run into a situation where you had oxygen here was definitely going to be changing, but now you had two oxygens to pick from, so which one would you pick? So it's going from a -2 state, and so you want to pick the one that it's going to change to. You're going to pick it with oxygen. Yeah, I wouldn't pick this one because it's still the -2. And you can see that the lead goes from a +4 to now a +2. So now I've got red and blue here. You probably just have pencils. Go ahead and write in which one is gaining electrons, which one is losing electrons. And when I do that, I see that lead has now gained 2 electrons since it went from a +4 to a +2. So it's now gained a -2 charge. And then oxygen has gone from a -2 to a 0. So now it has lost a -2 charge. Once this is done, it's easy to now use the oil rig pneumatic to now see which one is oxidized, which one is reduced. The one that's oxidized is the one that lost, so that would be oxygen, and then the one that's reduced is going to be lead. So now, which one would be the oxidizing agent or the reducing agent? Those are going to be reactants. Well, now since I only have one reactant, they're both going to be oxidizing agent and reducing agents. Yeah, that can happen. I think that's why they kind of don't really put it on the AP test. Okay guys, thanks for watching. The goal of this video was to teach you the oxidation states and just to get a feel for the oxidation and the reduction, and just to kind of understand kind of what it means. We're not done with this stuff yet. We still got more to learn, and that's going to come in the next video. All right, thanks guys.